Now let's proceed to the resistance levels. So semiconductors react differently to DC and AC current. So there are three types of resistance. First is the DC or the static resistance. Second is the AC or the dynamic resistance. And third is the average AC resistance. So for the DC static resistance, for a specific applied DC voltage, there is a specific resistance and current. So for example, determine the DC resistance levels for the diode at A 2 milliamperes, B 20 milliamperes, and C for negative 10 volts. So let's solve first letter B. So resistance is equals to voltage divided by current. So for the 20 milliamperes, we have a 0.8 volts. So this is equal to 0.8 divided by 20 times 10 to the power of negative 3 amperes. So this is equal to 40 ohms. And for letter A, resistance is equal to 0.5 divided by 2 times 10 to the power of negative 3. So this is equals to 250 ohms. And for letter C, resistance is equal to 10 divided by 1 times 10 to the power of negative 6. So we got this 1 times 10 to the power of negative 6 in the graph for the negative 10 volts. So this is equal to 10 milliohms. So to conclude, we can say that C is less than A and A is less than B. While for the resistance for each results, so 10 milliohms is greater than 250 ohms, and 250 ohms is greater than 40 ohms. So therefore we can say that resistance is inversely proportional to the current. Next is the AC dynamic resistance. So in the forward bias region, so the resistance depends on the amount of current in the diode. Then the voltage across the diode is fairly constant, 26 millivolts for 25 degrees. So it is constant and ranges from a typical 0.1 ohms for high power devices to 2 ohms for low power general purposes diodes. In some cases, RB can be ignored. So in the reverse bias region, RD is equals to infinity. The resistance is effectively infinite. The diode acts like an open. And lastly, for the average AC resistance, so R average is equals to the change in voltage T over change in current D. So this is from point to point. So AC resistance can be calculated using the current and voltage values for 2 points of the diode characteristic curve. So this means that in average AC, resistance is determined by a straight line drawn between the two intersections obtained by the maximum and minimum values of input voltage. So for example, the minimum voltage is 0.650 voltage, and the maximum voltage is 0.725 voltage, while the current minimum is 2 milliamperes and current maximum is 17 milliamperes. So let's solve for the average AC resistance. So the average voltage is equal to 0.725 volts minus 0.650 volts is equals to 0.075 volts. So our current change in current is 17 milliamperes minus 2 milliamperes is equals to 15 milliamperes. So our resistance average resistance is equals to 0.075 volts divided by 15 milliamperes. So this is equals to 5 ohms. So therefore, our average AC resistance is equals to 5 ohms. So the diode equivalent circuit. So it is the combination of elements like resistor, capacitor, and conductor, so properly chosen to best represent the actual characteristics of device in a particular operating region. So here we can see that there is a voltage source, a resistor, in the ideal diode. For the diode capacitance, so here you can see for the reverse bias, we have the capacitance or the barrier capacitance, which changed changed only with the increase in voltage, while the diffusion capacitance is it is considered as the storage capacitance, which is larger than uh, the barrier capacitance. So also, this is also directly proportional to the current and the voltage. Reverse recovery time. So this is time required for the diode to stop conducting once it is switched from forward bias to reverse bias. So dito nangyayari yung on and off. So change of state. So ito nangyayari yung switching from the conducting to the blocking state. So kapag ang voltage applied ay kailangan mag-reverse para makagawa ng reverse bias situation, makikita natin yung instantaneous change from conduction to non-conduction. Now here we are at the diode specification sheets. So data about the diode is presented uniformly for many different diodes. So this make cross-matching of diodes for replacement or design easier. So we have here the forward voltage at a specified current and temperature. Number 2, maximum forward current at a specified temperature. So, ito na yung mga topic natin kanina. So number 3, reverse saturation current at a specified voltage and temperature. So number 4, reverse voltage rating or PIV or PRV or V quantity BR at a specified temperature. So maximum power dissipation at a specified temperature, capacitance levels, reverse recovery time, and operating temperature range. And next is the diode symbol and packaging. So A is the abbreviation for anode, and K is the abbreviation for cathode. Next is the diode testing. So we have here the different ways to test the diode. So we have here the diode checker, the ohmmeter, and the curve tracer. So first is the diode checker. So many digital multimeters have a diode checking function. So makikita natin ito sa mga multimeters, multitesters like that. So the diode should be tested out of circuit. So a normal diode exhibits its forward voltage for the gallium arsenide, which is 1.2 volts, silicon diode a 0.7 volts, and germanium diode, which is 0.3 volts. Second is the ohmmeter. So an ohmmeter is set on a low ohm scale, can be used to test a diode. So the diode should be tested out of a circuit. So itong ohmmeter is pang measure siya ng resistance. So for example, we have here the forward bias, which is it has a relatively low resistance, while for the reverse bias, it has a relatively high resistance. So next is the curve tracer. So a curve tracer displays the characteristic curve of a diode in the test circuit. So this curve can be compared to the specification of the diode from a data sheet. So this is use of a data sheet. So this is to analyze the characteristics of discrete semiconductor devices. So we have here the other types of diodes. So we have the Zener diode, the LED or the light emitting diodes, and the diode arrays. So the Zener diode na discuss natin kanina, so it is a diode operated in reverse bias at the Zener voltage. So ito yung may Zener breakdown sa Zener region. So common Zener voltages are between 1.8 volts and 200 volts. So LED or the light emitting diode, so this emits protons when it is forward biased. So parang pareho lang ito ng PN junction, which meaning that LED will pass current in its forward but will block current flow in the reverse direction. And for the last one, the diode arrays. So multiple diodes can be compact together in an integrated circuit. So for example, this common anode. So there are 11 common anodes, and there are also common cathodes. So parang iniisa lang sila. So they are packed together. So